Hello dear students, welcome back to a new video. Now in this video you're going to have a full revision of grade 10 physics. Now I'm going to focus mainly on the important things that you're going to need and where students tend to make mistakes and what you actually need to pass the exam. Okay, so you have section 1 from chapter 1. We have what is physics. Okay, so we have studied that physics is the study of how things move and work in the world. The word physics means life or nature. So we have several areas in physics. The first one is what? The first one is mechanics. Okay, we have several areas in physics. We have mechanics. Mechanics is about what? Whenever you see motion, it means we have a situation where it is related to mechanics. For example, an object is falling to the ground, or for example, you are riding a bicycle, or for example, you are playing football. These situations, they are all related to motion, and motion is related to mechanics. Or for example, the wheel of a tire or of a bicycle is spinning. Okay, this is also related to mechanics. So spinning objects, falling objects, friction, weight, these are all examples of mechanics. Okay, then we have what? Thermodynamics. Thermodynamics, anything that is related to heat and temperature. For example, you are cooking dinner. Okay, if you feel hungry and you want to eat something, so you're trying to what? You're trying to prepare something. So preparing dinner is related to what? To thermodynamics. Why? Because we have heat and we have temperature. Okay, so melting, freezing, these are all examples of what? Examples of thermodynamics. For example, you want to, for example, freeze a bottle of water, so you put it in the refrigerator, and then it's going to be what? It's going to be frozen. Okay, you want to melt down some ice. Okay, so you put it on a hot stove, and it's going to what? It's going to melt down. So these are all examples of heat and temperature, which is related to thermodynamics. Vibrations and wave, whenever you see the motion of an object that is repetitive, okay, for example, a spring, okay, when you stretch a spring and you leave it, you're going to see that spring goes up and down, goes up and down, okay, so this is what? This is a repetitive motion. Sound is also a repetitive motion. Why? Because the particles of the air are vibrating in a fixed position, okay, they're moving forth and back and forth, okay, so this is what? This is also an example of vibrations and wave. Pendulum, springs, these are all examples of vibrations. What do you mean by a pendulum? For example, you have a ball, you tie this ball to a rope and you let it swing. Okay, you see that this ball is going to what? Is going to be going forth and back. Okay, back and forth. Now we have optics. Optics, anything that is related to light. Okay, especially the interaction of light with lenses, with mirrors, and of course color too. Okay, so mirrors, lenses, color, astronomy too. Astronomy is also related to optics. Why? Because we use light to gain information from stars. Also colors, they're also related to optics. Electromagnetism we have. Okay, so you can just recognize it by what? By electro and magnetism. Okay, electro and also magnetism. Electro and magnetism. Whenever you have magnets or electricity, they are related to what? They're related to electromagnetism. Relativity and quantum mechanics. You don't have any examples of those in the book, but just know that it's about particle collision, and quantum mechanics is about the behavior of subatomic particles. In the car, you can see many examples of the areas of physics. Now we have what? We have scientific methodology. Scientific methodology is basically a systematic method of studying natural phenomena. For example, you are searching about something, or you are trying to study a phenomenon in physics. Okay, a phenomenon can be anything. Okay, let's say you want to know the behavior of falling objects when you increase the mass. Okay, this is basically a phenomenon. Okay, so scientific methodology or scientific method is basically a system that we follow, or some steps we follow to study a natural phenomenon. Okay, so a systematic method of studying natural phenomenon. It has what? It has 6 steps. Okay, the first one is observing and asking questions. Okay, observing and asking questions. For example, you are studying a phenomena, you're going to observe the phenomenon and you're going to ask questions about it. Let me give you an example. Let's say You are trying to, um, a smell, let's say, a smell is coming from the house, and you want to what? You want to observe and ask questions about it, okay? Let's say you're having dinner and suddenly you smell something, okay? And you ask your parents or you ask your siblings, do you smell that too? So you observed. Observing means using five senses, okay? So you smelled, it means you observed, and you started asking questions. You said, you asked your father, you asked your mother, do you smell that too? Okay? So observing and asking questions is the first um, step. Building hypothesis, okay, without checking, okay, you're going to say that maybe the smell is coming from the kitchen. So this is what? This is hypothesis. It's not correct to say it, but let's say it's just a prediction, okay, but it's not correct to say it. Building hypothesis, okay, I'm going to give you another example about this. Let's say you are trying to buy a new car, okay, so you first what? You first observe and ask questions. You ask your brother, you ask your father because they own a car. You're going to ask him what car is good, okay, or what car might work for me. So you observe and you ask questions. Then you build hypothesis. You're going to say what? You're going to say that probably Nissan is a good car, okay. Then you test the hypothesis. You're going to test multiple cars. Let's say you're going to test Nissan, Toyota, Mercedes, BM, and then you analyze your data. You're going to collect all the data from each car, and then you're going to deduce results, and then you're going to publish those results. Okay, so this is the scientific methodology. This is a longer version of it. Just know that system is a precise part of the studied region and the observation, and model is a simplified look of the system. Okay, a system, it can be anything. For example, a car is a system that I can study it. Okay, a toy car is what is a model. Okay, a real heart, okay, you have heart, okay, you have a heart, is a system. But a fake one, which your biology teacher brings it to the class, is what is a model. Okay, so model is basically a simplified look of the system. This is all just a longer explanation of the of scientific methodology. Controlled experiment is with an experiment where a single variable is changed while the others are fixed. Okay, this is also explanation for the scientific methodology. It's just repetition. Section review, I'm going to go over this very quickly. Name the areas of physics, mechanics, thermodynamics, vibrations, and wave phenomena, optics, and etc. Identify the areas of physics that is most relevant to each of the following. A football game, a football game, players are running, okay, and there is friction also, so it's what? It's mechanics. B, preparing dinner. What do you need to prepare dinner? Of course, you need heat. Okay, let's say you're cooking something. So this is what? This is thermodynamics. Be careful. Hearing the call for evening prayer. Hearing the call for evening prayer. So the call for the evening prayer is sound. Okay, sound is a repetitive motion, so it's related to vibrations and wave phenomena. Lightning in a thunderstorm. Lightning is the discharge of negative and positive charges. Okay, lightning is the discharge of negative and positive charges. So it's what? It's related to electricity. Okay. The question says most relevant. Be careful. If it says more than one area or two areas, I can say that lightning is also optics. Okay. But be careful. Lightning is different than thunder. Thunder is sound. Lightning is like the light itself. Okay. Wearing a pair of sunglasses. Okay, this is optics because you have sunglasses. What are the activities involved in the scientific methodology? Count what? The activities here means the steps. Okay, I can easily say, or I can easily change the question and say, what are the steps involved in a scientific method? Okay, so observe and ask questions, build hypothesis, test hypothesis, and then at the end. Question 2, give 2 examples of ways that physicists model the physical world. You have computer simulation and diagrams. Okay, this question is important because it says identify, it's related to the second question, but differently. It says identify the areas of physics involving each of the following tests of a lightweight metal alloy proposed for use in sailboat hulls. Testing the effects of collision, okay, because you have collision, so this is related to mechanics. Be careful. Okay. Question B, it says testing the effects of extreme heat because you have heat, so it's related to thermodynamics. see whether the Allah can affect a magnetic compass needle, because you have magnetic. Look at the areas of physics and which one has the word magnetic in it. Of course, electromagnetism. So see, this is related to electromagnetism. Okay, you have measurements in physics. Dimension is basically a specific physical quantity, the measure of a specific physical quantity. We have many dimensions in physics. One of them, for example, is length. Mass is also a dimension. Okay, so look at it, please. We have these fundamental units in physics. Your teacher brings this in the exam and says, what are the fundamental units in physics? Some students make this mistake that they're going to memorize all of these. Okay, they memorize all of these, they know, but they don't know that this table is the table of fundamental quantities in physics. Read that too, please. So length, which is measured in meter, be careful. You have mass, which is a fundamental unit too, it's measured in kilogram. And then until luminous intensity, which is measured in candela. Okay, these are the fundamental units in physics. Please memorize them. Okay, then let's take some examples from these ones, and how can we derive the units. Okay, these ones, guys, there are some derived units from the fundamental units that you saw. Okay, so all the other units that you see in your physics studies, these are all derived units from the fundamental ones. Okay, so you have area, which is equal to length multiplied by width. Length, you know, is measured in meter. Width is also measured in meter. The unit for area is meter squared. Okay, this is a derived unit. Okay, meter is a fundamental unit, and the area is measured in meter squared. Let's take, for example, volume. You know, volume is length, width, and height. Length is measured in meter, width is also measured in meter, and height is also measured in meter. So I have 3 meters. Multiply them and add the powers together. 1, 2, 3. So meter cubed. The unit of volume is meter cubed. Okay, you have speed, which is equal to distance divided by time. Distance is measured in meter. Time is measured in seconds. Okay, distance, by the way, is the same as length, so you measure it as meter. Okay, we have energy. I'm going to take energy. Energy is equal to what? Is equal to force multiplied by distance. Okay, force is measured in Newton. Okay, and distance is measured in meter. We have what? We have joule. Okay, and these are some examples that you saw. Okay, but be careful. Some of these units, they can be expressed differently. For example, this is Newton and this is meter. So I can say that joule can be expressed as both Newton meter or joule. Okay, Newton also, which is the unit of force, it can be expressed like this too: kilogram. Okay, meter per second squared. So your teacher brings this back in the exam and says, which one of the following are units of force? It's either Newton or this one, or it can be both. Be careful. It can give you both in the question. So memorize these derived equations too. Okay, so we have prefixes. This is basically unit conversion. Let's take some examples. Let's say you have 23 kilometer. Okay, before we do that, let's check the prefixes. So the prefixes are what? Okay, we have tera, it's 10 to the power of 12, giga, 10 to the power of 9, mega, 10 to the power of 6, kilo, 10 to the power of 3, hecto, 10 to the power of 2. Then we have centi, 10 to the power of negative 2, milli, 10 to the power of negative 3, micro, 10 to the power of negative 6. In the question, in the book, it says mega until micro, I think. Memorize just these. But your teacher might also recommend that you memorize all the others. It depends on the teacher, okay? Now, let's take some examples. We have what? we have, let's say, kilo. 23 kilometers. It says change it to meter. 23 kilometers. Change it to meter. But first, let me drink some water. Okay, it says 23 kilometers. Change it to meter. Okay. When you have a prefix, okay, so you have kilo with meter, okay, don't do anything. Okay, so you write the 23 like this, multiply it. Kilo is 10 to the power of 3. Because you want to remove kilo, okay, so you are removing, you are removing, so just multiply it by 10 to the power of 3 meters. Okay, that's it. Okay, don't do anything else. Let's take another example. Let's say this time you have 32 microsecond. You are changing this to what? To second. Okay, so you want micro to go. Okay, so you are removing. Okay, removing. Okay, so you are removing micro. Okay, you want seconds alone. So what are you going to do? Just write 32 times micro is 10 to the power of negative 6. So multiply by 10 to the power of negative 6. Don't forget the final unit, 10 to the power of negative 6. And this is true for all the others. If you remove, just remove the prefix and instead of it, add powers of 10. What if it's the opposite way? What if it's the opposite way? So let's say you have 3 meters. You are changing this to kilometer. Okay, so this time meter is alone and I'm trying to add what? Add kilo. Okay, so this is adding. Kilo is 10 to the power of 3. Okay, so what are we going to do? We're going to say 3 times 10 to the power of 3 kilometers. But because you are adding, so change the sign of the power. Okay, so it's going to be negative 3 kilometers. Okay, let's take another example. Let's say we have, let's say 6 or 60, let's say 2 grams. We didn't take gram. Change this to milligram. Okay, so gram is alone. You want to add what? You want to add milli. So this is what? This is adding. Okay, milli is how many? 10 to the power of negative 3. So this is going to be what? This is going to be 62 times 10 to the power of negative 3 milligram. But because you are changing this, or you are adding the milli, so you have to what? You have to write the powers of 10 but with opposite sign. So this is going to be 10 to the power of 10 to the power of 3 milligrams. Okay, so this is basically unit conversion. But what if, let's say we didn't take this one. What if you have 2 prefixes? Let's say you have 2 millimeter and you are changing this to kilometer. Okay, so you have 2 prefixes. What do you do this time? Take the common one. Meter is the common thing between them. So first change milli to what? To meter, and then change this meter to kilometer. Okay, so let's do it. Okay, we're gonna have what? We're gonna have 2 times 10 to the power of negative 3 meter. Because I'm what? I am removing the meter from milli. So I have to add the powers of 10 as they are. Okay, now we change that to meter. Let's change that to what? To kilometer. Okay, so 2 times 10 to the power of negative 3 times 10 to the power of, because I am adding kilo, okay, so I have to what? I have to also say this is 10 to the power of 3, but because I am adding it to this number, it's going to be negative 3 kilometers. So 2 times 10 to the power of negative 6 kilometers. This is how you change prefix to prefix. This is basically unit conversion. And for units of time, these are units of time. 1 hour is equal to 60 minutes, 1 minute is equal to 60 seconds, and 1 hour is equal to 60 multiplied by 60, you have 3,600 seconds, okay? If you change um, great units or large units to small units, you multiply. For example, 1 hour, change it to seconds, you're going to multiply by 60 and multiply it by 60 seconds too. But if you change small ones to big ones, you have to divide. For example, you have 1,000 minutes, change it to hours, you're going to divide it by 60. Okay? Now, we also have what? We also have converting units of speed. Okay? So if you change kilometer per hour to meter per second, if you change kilometer per hour to meter per second, multiply the number by 5 divided by 8. Okay? So let's say you have 60 kilometer per hour. You are changing this to meter per second. So 60 multiplied by 5 divided by 18. Okay, so you have what? You have 16.67 meter per second. Okay? And if you change meter per second to kilometer per hour, it's 18 divided by 5. Sample problem A, this is also just unit conversions. Try to do them too. Okay. Chapter 1 is not that difficult. You can, I think most students can easily deal with it. It's basically unit conversion and areas of physics. Okay. So you have accuracy and precision. What is accuracy and what is precision? Accuracy is how close the measured values are to the true value. Accuracy is how close the measured values are to the true value, while precision is the degree, or it's how close the numbers are to each other. Okay? Errors in experiments. So we have two types of errors in experiments. We have human error and we have instrumental error. Human error, it means it comes from humans. For example, you miscalculate something. Okay, you don't know how to calculate the question. Okay, so this is basically, or you forget to write a number. This is basically human error. Instrumental error, it means, for example, let's say you have a calculator and this calculator is not working properly. The error is not from you, it's from the calculator. Okay, so this is what? This is instrumental error. How can we avoid, and by the way, one type of human error is parallax. Parallax is when you read different numbers differently because of looking from different angles. Okay, so let's say the true value should be like, you should read the ruler like this, which is 3.9 centimeters. But if you look from this angle, you're going to see 4 centimeters. And if you look from this angle, you're going to see 3.8 centimeters. This is called parallax, and it happens because we look at the same quantity from different angles. How can we avoid human error? Okay, how can we avoid human error? Just basically take repeated measurements. That's it. Okay, so you take repeated measurements and you're gonna see what? You're gonna see you have solved or you can have avoided human error. How can we avoid instrumental error? Instrumental error can be avoided by what? By checking the quality of what? Of the instruments that you're using. Okay, so always check if your calculator is working properly. Okay, and always what? Always check if it has a good quality. Okay, so this is basically what, how can we avoid instrumental errors? We have significant figures and we have some rules for significant figures. Okay, the first rule, it says zero between non-zero digits are significant. Okay, zeros between non-zero digits are significant. For example, let's say 500.1. Okay, how many significant figures do I have here? I have 1, 2, 3, and 4. So I have 4 significant figures. Okay, significant figures. Okay, 4 significant figures. The second rule, it says zeros in front of non-zero digits are not significant. Okay, so zeros, for example, like this, let's say you have 0.000, let's say 9. How many significant figures do I have? Only 1. Okay, but what if I remove this 0 Okay, what if I remove this 0 and I make it like this? This time I should calculate all the zeros. So 1, 2, 3, 4, 5, and 6. So I have 6 significant figures now. Okay, be careful. Zeros like this are not counted. Okay, let's take another example. Let's say you have 0.0, let's say 102. How many significant figures do I have? So 1, 2, 3. Be careful, I'm going to calculate this number. Why? Because it is between two non-zero digits. Okay, so 1, 2, 3. These two are not called significant figures. Be careful. Now, what is the third one? Zeros that are at the end of a number and also to the right of the decimal are significant. Okay. Now, if you have this number 9, okay, let's not say 9, 5, okay, 0.000. Okay, how many zeros I have after the decimal? Be careful, I placed a decimal. Okay, zeros after the decimal are all counted. If you have 1 million zeros after the decimal, they're all counted. So how many significant figures do I have? So 1, 2, 3, 4. 4 significant figures. Be careful. Now, zeros with numbers that they don't have decimal are not considered significant if they don't, or if they are not between two numbers. For example, let's say you have 1 million. Okay, 1 million. Okay, how many significant figures do I have? Only one. Be careful. Only this one is counted. These 6 zeros are not counted. So I only have one significant figure. Okay. Some of you might say, what about now? Be careful. The zeros now are between two numbers. So 1, 2, 3, 4, 5, 6, 7, and 8. I have 8 significant figures. But if there are zeros alone, don't count them. You have 202, let's say, 1,000. How can you, or what are the number of significant figures here? Be careful, these 3 are not counted. Why? Because they're at the end of a number, but this 0 is counted. So 1, 2, 3. These are basically significant figures. The other ones, these are just multiplication and addition. I don't think you're going to be needing them. Okay. Section 1, 2, it says, which SI unit would you use for the following measurement? So when you are using a unit for a measurement, they should be appropriate. Okay, for example, if it's a swimming pool, I cannot say miles or kilometers. Okay, and I cannot say millimeters basically, or I cannot say centimeter because it's too small. Okay, so it says, which SI unit would you use for the following measurements? Okay, swimming pool, I'm gonna use meter. Okay, the mass of the water in the pool, it says the mass. Don't say because it's water, so you're gonna say liter. No, it's mass of the water, so it's going to be kilogram. Be careful. Okay, the time it takes a swimmer to swim a lap, seconds. It should be SI unit. Be careful. Don't say tons and things like this because ton is not an SI unit. Okay, and do the other questions yourself. These are just basically changing and converting one unit from another into other prefixes. Okay, so you have these, which is what this one is the real value. This is the density, which is the real value. Okay, I'm going to call this real value. Now, this is which one are precise and which one are accurate. So, precision is what? Precision is how close the numbers are together, while accuracy is how close the numbers are to the true or to the real value. Okay, so adding, he measures and he gets 11.32, 11.35, and 11.33. Are these numbers close together? Yes, they are close together, so I'm going to call them precise. Okay? Now, are these numbers close to the real value? Yeah, 11.32 is close to 11.34. 11.35 is close to 11.34, and 11.33 is close to 11.34. So this is also what? This is also accurate. Be careful. What about the second one? He got 11.43, 11.44, 11.42. Are the numbers close together? Yes, so they are precise. Are the numbers close to the real value? No, so not accurate. Be careful. They are not accurate. The third one, he got 11.55, 11.34, and 11.04. Are the numbers close together? No, so not precise. Are the numbers close to the real value? This is the real value, 11.34, so they are not accurate too. Okay, so precision is basically how close the numbers are to the what? To each other, and accuracy is how close the numbers are to the true value. Do these calculations yourself, they're not that important. We have what here? We have order of magnitude, which is really important, the nearest power of 10 to the value of the physical quantity. So you get a question like that. What is the order of magnitude of 725 kilometers? So you know 725 kilometers is close to what? It is close to 10 to the power of 3. What is the order of magnitude of 84 kilogram? So it's 10 to the power of 2. Why? Because it's closer to 100. What is the order of magnitude for 12.5? It's 10 to the power of 1. These are some really important notes. If it says mountain, okay, mountain, the order of magnitude is 10 to the power of 3. If it says building, okay, this is 10 to the power of what? 10 to the power of 2, for example. But be careful. Skyscrapers are different than buildings. Okay, building, for example, hospital, school, these are 10 to the power of 2. But skyscraper, for example, like Burj Khalifa, this is what? 10 to the power of 3, because it's really, really high. Okay, but building, for example, hospital, school, these are 10 to the power of 2. Okay, be careful. Houses, okay, your house is 10 to the power of 1. Okay, human body, the height, the order of magnitude for the human body height is 10 to the power of 0. Okay, why? Let's say this is meter, meter, and meter. Why? Because 10 to the power of 0 is equal to what? Is equal to 1 meter. Okay, now insects, we can say 10 to the power of negative 3 meters. Okay, so these are some order of magnitudes that they're really important. Question, section 1-3, question 1 and 2, I don't think they're that important. Let's move on to question 3. This is really important. So it just basically say determine the units of the quantity described by each of the following combinations. So you have kilogram, meter per second, multiplied by 1/second. So write kilogram like that, okay? And this one, say meter divided by second, okay? And this one, 1 divided by second, okay? So meter multiplied by this one, so you have what? You have kilogram, okay? And then meter multiplied by 1 is still meter. And then second multiplied by second is second squared, okay? And then kilogram multiplied by meter, you have kilogram meter per second squared. We studied that this one is what? This is Newton, be careful. This one, guys, you have what? You have kilogram multiplied by meter, and you have second multiplied by second. So kilogram meter per second cubed, okay? This one, guys, this one is really important. So you have kilogram divided by second, okay? But you have what? You have squared. So this square goes for the meter, and it goes for the second too. So meter squared divided by second squared. And multiply this by this, multiply this by this. You get what from this? You have kilogram meter squared divided by second cubed, okay? And do the others yourself. They're really, really easy. You have this last one left. Question 4, it says, which of the following is the best order of magnitude for a mountain? So you remember that we said the height of a mountain, or the order of the height of a mountain is what? 10 to the power of 3. 10 to the power of 0 meters is 1 meter. Okay, so it's really, really short. 10 to the power of 1 is 10 meters. Is a mountain 10 meters? Of course not. Okay, is it 1 meter? Of course not. 10 to the power of 2 is a mountain close to 100 meter? Of course not. 10 to the power of 3 is 1000 meters. So this one is what? Is the order of magnitude for a mountain. What if I make this school? Okay, if I make this school, it's going to be 10 to the power of 2. If I make this one, for example, not school, but house, okay, this is going to be what? 10 to the power of 1. And if I make this a human body, and it's going to be 10 to the power of 0. So we finished chapter 1. We're going to move to chapter 2. You can solve the practice chapter review and assess yourself. The questions are not that difficult. Only the ones that we focused on here, like the topic we focused on, just solve those ones. Okay, so question chapter 2 is about what? Strength of solids. The first section we have what? We have phases of matter and forces among the molecules. Phases of matter, you have studied before, you have what? You have solids, liquids, and you have gases too. Okay? Liquid, solid, and gases. Gases, the particles are close together. Okay? The particles are really close together. That is why they have what? They have a definite shape and they have a definite volume too. Your teacher asks you in the exam and says, why solids, they have a definite shape? Because the particles are close together. Okay, be careful. Solids, they cannot be compressed, okay, because they have a high density and particles are close together too. Liquids, the difference between liquid and solid is really important because some students still confuse that. They say that liquid or particles of liquid are not close together. Be careful. Particles in liquid are close together, but they can move over each other. Okay, they can move over each other. That is why liquids, they don't have a definite shape, but they have a definite volume. Okay, so definite volume, but no definite shape. For solid, we have definite volume, definite shape. Be careful. Liquid, it takes the shape of the container. For example, we have a glass. For example, this glass, you see that the water takes the shape of this container. Okay, so liquid takes the shape of the container. Gases, the particles are far away from each other. The particles are far away from each other, so they have no definite volume and they have no definite shape too. Definite shape. But something is really important, which is that gases, they have the highest compressibility. Why? Because particles are far away from each other. You can compress them easily. Liquids, they cannot be compressed because particles are close. Solids, they also cannot be compressed because particles are close. We also have another phase which is called plasma, a phase of matter achieved at very high temperatures. Examples in stars, aurora, or lightning. This is really important. You have a question in the chapter review. It says, why most of the universe is in plasma state? Most of the universe is in plasma state because most mass in the universe is concentrated in the stars, and stars are in plasma state. That is why 90, and some scientists say 99% of the universe is in plasma state, because most stars are plasma and most mass in the universe is concentrated in the stars. Okay, this question is really important. It says, how can you change the phase of a material? Okay, using two things, mechanical or thermal energy. Okay, be careful. These are the differences between solid, liquid, and gases. Why is it difficult to compress solids? Because the particles are close. This one. You have repulsion and attraction force between atoms. If the atoms become too close, you have what? You have the force which is repulsive. If the atoms are too far away from each other, you have attraction force. And if they are just in the right place or in the right what we call distance, then the force is equilibrium. Okay, so let's say these are two atoms. The equilibrium distance between them is, let's say, this, these two atoms, let's say they cross the equilibrium distance and they get too close. So the force becomes what? Becomes repulsive. Be careful. Okay? What if you have two atoms this time? This is the equilibrium distance between them, but this time they are far away from each other. So they have crossed the equilibrium distance. So this is the new distance and this is the new distance. Okay? So R is greater than R naught. Here, guys, R is smaller than R naught. So this is going to be what? This is going to be attractive. What if you have two atoms, but they don't change the R naught, and R naught equals R, so this is equal to, or this is called equilibrium state. Be careful. This is just basically when it comes to attraction and repulsion force between the atoms. Bond is basically a force leading to the attraction among the atoms, okay, or mutual interaction among its positive and negative charges. We have three types. Ionic bonding happens when an atom donates and the other atom receives an electron. Okay, so donating and receiving electrons is ionic bonding. Example of it is crystals of sodium chloride. Okay, so ionic bonding happens when one atom donates an electron and the other atom receives an electron. Okay, the atom that receives the electron becomes negative ion, and the one that donates is positive. Example of ionic bonding is crystals of sodium chloride. Covalent bonding happens when two atoms, they cannot donate or receive electrons, so the solution for them is sharing. Okay, so covalent happens when atoms are shared between two, when electrons are shared between two atoms. Example is oxygen. Metallic bonding happens when you have one free electron and it's moving freely inside a sea of electrons. Okay, so we have these equations, please. Density is equal to molar mass divided by molar volume. Mass of one atom is molar mass divided by Avogadro's number. Avogadro's number is going to be given in the exam. And volume of an atom is equal to what? Molar volume divided by Avogadro's number. And we have distance, which is equal to cubic root of volume. So let's solve a question about this. Okay, we have sample problem 2a. Sample problem 2a. Estimate the distance. This question is really important because you use all the equations you learn here. It says what? It says estimate the distance between two atoms. So what do we need? We need length between these two atoms. Knowing that its molar mass is 0.064. So molar mass is equal to 0.064 kilogram. Okay, 0.064 kilogram. And its density is equal to 8,000 kilogram per meter cubed. And Avogadro's number, Na, is equal to 6.02 times 10 to the power of 23 mole inverse. Okay, now the question says estimate the distance. Okay, so you know the equation for distance is equal to what? Length cubic root of what? Of volume. Look at here and you don't have volume. Okay, before that, let me tell you the difference between volume and the molar volume. Guys, volume is volume of one single atom. Molar volume is volume of all the atoms that you have. Okay, be careful. Here we need volume of a single atom. Be careful. Okay, so distance between two atoms. What do I use to find volume of a single atom? I'm going to use this equation. Volume is equal to molar volume divided by Avogadro's number. You look at here and you also don't have molar volume. Okay, how can I find molar volume? How can I find molar volume? So I'm going to say density is equal to what? Molar mass, divided by molar volume. Okay, so I need this one here, molar volume. So molar volume is equal to what? It is equal to molar mass which is 0.064 divided by 8,000. Okay? Molar volume is equal to 8 times 10 to the power of -6, -6, its volume, so meter cubed per mole. Okay, now bring this number and put it here. Okay, so volume is equal to 8 times 10 to the power of -6 divided by Avogadro's number, 6.02 times 10 to the power of 23. Okay, if you calculate this, volume is equal to 1.33 times 10 to the power of -29 meter cubed. Be careful, because mole goes with the mole. Now, bring this number, length is equal to cubic root of volume. We found volume, it is equal to 1.33 times 10 to the power of -29. Okay, volume is length is equal to what? Or distance between the two atoms is equal to what? It is equal to 2.37 times 10 to the power of -10. Because you have meter cubed here, cubed goes with cubed, so you have meter left. So this is what? This is the length between these two atoms. Practice 2a, says the equilibrium distance between two neighboring atoms is 1.2 times 10 to the power of -10. So this is going to be our note, which is what? Which is the equilibrium distance. It's basically the distance that these two atoms should remain to be in equilibrium state. Okay, if the distance decreases, look, 1.2 to 1. The powers of 10 are the same, so don't care about that. 1.2 and 1. So the distance is decreasing. If two atoms get too close together, the force between them is going to be repulsive. Be careful. Okay? 1.4, so from 1.2 to 1.4, so the distance has increased. Okay? So the force is going to be attractive. Attractive force. And this one, repulsive force. Question 2, it says, what are the three types of bonds among the atoms? You have what? You have ionic bonding, you have covalent bonding, and you have metallic bonding. We said that ionic bonding happens when one atom donates and the other one receives. Example, crystals of sodium chloride. We have another example, which is what? We have another bond, which is covalent bonding. It happens when atoms are sharing electrons. Example, like oxygen. Metallic bonding happens when you have a free electron and then this free electron is moving freely inside a sea of electrons. It says, are these bonds due to electric forces or gravitational attractions? Of course, they are due to electric forces. Be careful. Section 2.1. Does matter change from one phase into another due to exchange of mass, charge, or energy? Okay, so if you have one glass of water and this glass of water turns into ice, does the mass change? Of course not. Does the charge change? Of course not. What does change? It's the energy that changes. For example, give this ice some heat, and because you have given this thermal energy, so it's going to be what? It's going to be changing the phase into what? Into liquid by what? By thermal energy. Repulsion between two atoms is due to interaction between the electrons. Is it because they're small? No, it's because of the charges. This question is also really important. It's the same as the question above. It says if R is equal to R naught, so if R is equal to R naught, what does this mean? It means that if the distance between the two atoms, let's say you have two atoms, if the distance between the two atoms, okay, it's the same and it doesn't change, okay? So what's going to be the force between them? The force between them is going to be what? Of course, this will not be repulsion or attraction. It's going to be equilibrium state. Equilibrium state. Be careful. Why? Because the distance does not change. B, if R is equal to 0, it means if the two atoms are too close together. Okay, so R is equal to 0, so it's going to be repulsive. Be careful. What if the distance between them is infinity? So take any number. Okay, R is equal to infinity. Okay, what is going to be what? The force between them is going to be attractive. Be careful. attractive force. So this is question 3. Question 4, this is also a good question. So let's solve this one too. We have the molar mass of sodium. So we have MM is equal to 22.98 gram. Okay, what is its molar volume? Vm is equal to what? If you know that the density is equal to 9.71 gram per centimeter cubed. One thing you should always care about is that are the units consistent or not? Okay, this is a small note which you should know, that kilogram comes with meter and gram comes with centimeter. So if in the question you have kilogram but you have centimeter, you should change centimeter to meter. In the question, if you have grams and you have meter, you should change this gram to kilogram, sorry. Here I have gram to here, and I have centimeter. So the units are consistent, don't change them, okay? This temperature, I'm not going to care about this temperature. So density is equal to molar mass divided by molar volume. I need this one. So molar volume is equal to what? Molar mass divided by density. Molar mass is equal to 22.98, okay, divided by density, which is equal to 9.71. This is equal to 2.37 centimeter cubed. Okay, this is question 4. Solids and their properties. Okay, we're going to talk about what? We're going to talk about the mechanical properties of solids here. So we're going to talk about the mechanical properties here. Before that, what are the factors that influence the arrangement of molecules? Okay, the factors, we have three factors, sorry. The shape of the molecules, okay, the shape of the molecules, okay, the magnitude of interatomic forces, and the temperature of the material, okay. We also have some questions like this here. What gives solids the definite shape? What gives solids the definite shape? The solids have a definite shape because they have a regular arrangement of atoms. Let me make a difference for you between liquid particles and solid particles. So let's say this is solid. Let's say this is solid. And this one is liquid. Okay? Liquid particles. Be careful that both of them are close together. But the particles in solid are what? Are regularly arranged. So regular arrangement. Okay, regular arrangement. But particles in liquid are what? Are randomly arrangement. Randomly arranged. So random arrangement. Random arrangement. Be careful. This random arrangement is going to give what? Is going to give the ability to water or to liquid to have no definite shape and to flow too, okay? So this is basically it. We have mechanical properties. These are the mechanical properties. We have rigidity, tension, stress, strain, Young's modulus, and elasticity. This might be a question in the exam. Your teacher asks you, what are the mechanical properties of solids? So we have rigidity, tension, stress, strain, Young's modulus, and elasticity. Be careful. Stress can be 2, tensile, okay, or compressive. Okay, compressive stress, or it can be shear stress too. Shear stress. So it can be given in multiple choices. It can be given in fill in blanks. So be careful about this too. So we have rigidity. Rigidity is basically the ability of an object to preserve its shape. Basically definition. And then we have what? We have elasticity. Elasticity is the ability of an object to go back to its original shape. For example, you have a spring. You apply a force on this spring. This spring is going to be stretched. When you leave it, the spring goes back to its original shape. You have a tennis ball in your hand. You compress this tennis ball, and it goes back to its original shape when you what? When you remove the force, okay? But what if you stretch the spring too much? Of course, this is going to what? This is going to exceed the limits of elasticity of this spring, and it's not going to be able to go back to its original shape. Be careful. What are the differences between elastic and inelastic bodies? Be careful. Elastic objects, for example, you have a paper and you have a tennis ball. A paper and a tennis ball. A paper cannot go back to its original shape when you remove the force. A tennis ball can easily go back to its original shape when you remove the force. The change in the paper is permanent. It never goes back to its original shape. The change of the shape is going to be like that. If I come back tomorrow, the change is still like that. Okay? But for a tennis ball, the change is temporary. It means for a short time. Okay, so elastic, it can go back to its original shape. Inelastic, it cannot go back to its original shape. Change in the inelastic is permanent. Change in inelastic is temporary. Examples for elastic, you have spring, tennis ball, rubber. Okay. Examples for inelastic, slime or clay. Okay. We have what? We have tension, which is basically a force. Because it says force, so you should know that it's measured in Newton. Tension is when you have a rope, okay, and you stretch or you compress this rope. Okay, you stretch or you compress this rope. A force arises in this rope that we call a tension. Okay, for example, when you tune the strings of a guitar, okay, you're gonna see that the strings, if you tune them too much, they're going to feel really, really tight. This tightness is basically tension. Okay, so tension, it's a force that arises in a body when it's compressed or stretched. Careful, because it's a force, so it's measured in Newton. Now, so we have tension. The symbol of it is like this, and it's measured in Newton. Okay, now we have stress. Okay, stress is what? Stress basically is what? Because you're going to study this in the next chapter, so I'm gonna make a difference for you here between stress and pressure. Pressure is equal to force divided by area. This pressure is external, okay? It means it, for example, you apply a force on a box. Let's say you have an object here. You apply a force, okay, over an area. Okay, so this is basically what? This is basically pressure. You also have something else which is called stress. Stress is equal to what? Tension divided by area. Okay, pressure is measured in Pascal, or we can say Newton per meter squared. Stress is also measured in Pascal. Why? Because tension is Newton, area is meter squared. Okay, so it's Pascal or Newton per meter squared. But what is the difference between them? Is that this one is internal. Stress is internal. Meaning you have the atoms, okay, here. When you apply a force on this object here, this is pressure. The reaction or the resistance of these atoms, okay, of course, they're going to resist, is basically stress. You have a balloon in your hand. When you apply a force on this balloon, this is pressure. Inside the balloon, you have air molecules. These air molecules are going to resist the change in their shape. So this is stress. Then we have what, guys? We have strain. Strain is basically elongation divided by initial length. Or you can say also delta L divided by elongation. This is also correct. It's not a big difference. Be careful that elongation is measured in meter. Initial length is also measured in meter. Okay, so meter divided by meter, they cancel each other. It's equal to 1. So be careful. Strain, it has no unit. Don't do the mistake of writing that strain has a unit. Okay, your teacher can give you something like this. What is the difference between stress and strain? Strain is the ratio between elongation and initial length. Stress is tension divided by area, or force divided by area, or force of a unit area. Strain has no unit. Stress is measured in Pascal or Newton per meter squared. Okay, so this is stress and strain. We also have Young's modulus, which is equal to stress divided by strain. This is my first equation. We also have this equation, which is tension multiplied by initial length divided by area multiplied by elongation. Okay, now, look, if I ask you what is the unit of Young's modulus, you know that stress is measured in Pascal. Strain, it has no unit, so the unit for Young's modulus is Pascal. Okay, be careful. And You also have something else which has the unit of Pascal. Stress has the unit of Pascal. Pressure, it also has the unit of Pascal. And all of them I can say Newton per meter squared. Be careful, okay? I talked about all of this. Be careful, tension with stress, they're directly proportional. If you increase, look at here please. So if you increase tension, stress also increases. With area, if you increase area, stress decreases. Okay, be careful. And oppositely is true. If you decrease the area, stress increases. What does stress depend on? Stress depends on tension and area. We have two types of stress. We have tensile or compressive stress. This happens when the force is perpendicular. We also have shear stress. This happens when the force is in the tangent direction of the cross-section of the object. Okay, so compressive, when the force is perpendicular, also tensile, perpendicular. Shear stress is the tangent direction. I talked about all of this. This question, what happens to a spring if a large force is applied to it and it exceeds the limits of elasticity? Of course, the spring will not be able to go back to its original shape. What are the 4 factors that affect the elongation of a wire? The magnitude of the tension, the radius, the length of the wire, and type of the material. I talked about this too. Let's solve a question about this. Okay. So we have this. It says a steel wire has a diameter of 0.4. So 0.4. A steel wire. A steel wire it has a diameter of 4. So diameter is equal to 0.4 millimeter. Whenever you have diameter divided by 2, so diameter divided by 2, 0. So it's going to be 0.4 millimeter divided by 2. Radius is equal to 0.2 millimeter. Be careful. Okay, it has an initial length. Initial length is equal to what? It is equal to 2 meters. And it's suspended vertically from a fixed position. It has 80 Newton. Okay, so tension is equal to 80 Newton. So the weight, it's also the same if you say tension. The resulting elongation L minus L naught is equal to 6.4 millimeter. What is the elongation, or what is the Young's modulus? Young's modulus is equal to what? Okay, now, so we're going to say what we're going to say. Young's modulus is equal to tension multiplied by initial length divided by area multiplied by initial length minus, elongation, sorry. Okay, now, I have tension, which is equal to 80. I have initial length, which is equal to 2. I don't have area. Okay, I don't have area. So let's find area here. Okay. You know what? Let's find area here. Area is equal to what? So why do you always change diameter to radius? Because I needed to find the area. So area is equal to what? Pi r squared. Pi multiplied by radius is equal to 0.2 millimeter. But don't do the mistake of using it like this. I need this in meter. So 0.2 times 10 to the power of negative 3 meters. Or you can say 2 times 10 to the power of negative 4 meters. So this is the radius. So 2 times 10 to the power of negative 4, all of it squared. Area is equal to 1.256 times 10 to the power of negative 7 meter squared. Okay, so this is area. I found area too, so let's apply the area here. Area is equal to 1.256 times 10 to the power of negative 7. multiplied by elongation. Elongation is equal to 6.4 millimeter. Please don't do the mistake of using it like this in the equation. 6.4 times 10 to the power of negative 3 millimeter. Change it to meter, please. Okay, so 6.4 times 10 to the power of negative 3. Young's modulus is equal to 2 times 10 to the power of 11 Pascal. This is question 1, sample problem 1. Solve the other questions yourself because this is a revision. I'm really sorry I cannot solve every question. I need this make video as short as possible. You have initial length, okay, initial length, and you have elongation. This is a good question. Strain is equal to elongation divided by initial length, okay? So 0.05 divided by 0.4, you have 0.125, but don't add any units because strain is unitless. This question solve it yourself. Okay, we finished chapter 2.2. Chapter 2.2, yeah. Let's move on to chapter 3. Chapter 3 is going to take some time too, so I'm going to quickly move over this. Chapter 3, we have what? Chapter 3, we have fluids, basically. Okay, so section 1, we have fluids and buoyant force. Okay, so what is a fluid? Fluid is a non-solid state. It means it's a state that is not solid. For example, liquid and gas. Okay, be careful. What are the properties of fluids? They can flow and they can change their shapes. You get this question in the exam. What are the properties of fluids? They can flow and they can alter their shapes. Why solids are not considered as fluids? Because they cannot flow and they cannot change their shapes too. Be careful. Okay, so this is basically a repetition of states of matter. We have what? We have mass density. Density is equal to mass divided by volume. Okay, so density is equal to rho. This is not P, be careful. Mass divided by volume. Mass is measured in kilogram and volume is measured in meter cubed. So the unit of density is kilogram per meter cubed. Be careful. Mass is what? Mass density is the mass per unit volume of a substance. These are some questions. You can have a look at them. And these are some densities of common materials. Something we are going to use a lot is fresh water, which is 1 times 10 to the power of 3 or 1000. Okay, and this one too, seawater, which is 1.025 times 10 to the power of 3 or 1025. Okay, now we have what? We have buoyant force and what we call apparent weight and weight of the object. So basically, buoyant force is when you have an object in a fluid and a force is applied on it. For example, when you are swimming, the force of the water on you is what is buoyant force. Okay. Why do objects feel lighter underwater? You get this question in the exam when than they do in the air, because fluids exert an upward force called buoyant force. Okay, I'm gonna move on over this. Apparent weight is the weight of an object in the fluid, okay, or in a fluid. If FB, this is really important, if FG of the object is greater than the FB, then the object is going to sink. If they are equal, it's going to be like that, standing in the water. It's not sinking and it's not floating. It floats if FB is the great force on the object. Be careful. Archimedes' principle, it says what? It says an object completely or partially submerged in a liquid, an object completely or partially submerged in a liquid or a fluid is going to experience an upward buoyant force. So this is the object. This is the object. It's going to experience an upward buoyant force, which is what? Which is equal in the magnitude to the weight of the fluid displaced. Okay, so the fluid displaced is equal to the magnitude of the buoyant force. So all of these equations you see here, okay? Before the equations, I'm gonna answer this question too. Why ships don't sink? Because ships, they displace or they have a greater exposure to the water. If they have a greater area or greater exposure to the water, they're going to displace more water. More water means more buoyant force. Be careful. Now, all of these equations you see here, okay, be careful. We have Fg divided by Fb, density of the object divided by density of the fluid. This is weight of the object, this is buoyancy, buoyant force, this is density of the object, and then this is the density of the fluid. In the question, it's not going to give you Fb. This is how you find Fb. Fb is equal to Fg minus Fa. What is Fa? It's the apparent weight we just defined. Fb is also equal to Fa minus Fg. You use this equation when the object is sinking. You use one when this one is floating. Okay, so let's move on. Let's solve this question. A bargain hunter purchases a gold crown. Okay, a bargain hunter purchases a gold crown. She weighs the crown first in the air. Okay, it doesn't say in water. So Fa is going to be what? 7.84. Fa is 7.84 Newton. Then she weighs the crown in the water, and the scale reads, so this is not Fa. This one is Fg. Fg is equal to 7.84 Newton. And Fa, which is the weight of the object while it's immersed in water, is equal to 6.86 Newton. Is the crown made of pure gold? You should find the density of the object and find out. Density of the fluid we know because it's water, so it's going to be 1000 kilogram per meter cubed. Okay, let's find density of the object. So we have Fg divided by Fb, density of the object divided by density of the fluid. Okay, now I don't have Fb. How do I find Fb? Because the object is sinking in the water. Gold, or this object, is denser than water. So Fg minus Fa. Okay, Fg is equal to what? 7.84 minus Fa, which is equal to 6.86. I'm gonna get 0.98 Newton. This is Fb. I found that too. Now, cross multiplicate this one. I'm not going to be needing this. Just I'm going to know that Fb is also Fb is equal to 0.98 Newton. Okay. Now, I need this one. Okay, so cross multiplicate. Okay, cross multiplicate. Fg multiplied by density of the fluid is equal to what? Fb multiplied by density of the object. So you need this one here divided by Fb and divide this side too by Fb. Fb cancels. Density of the object. Density of the object is equal to what? It is equal to Fg multiplied by density of the fluid divided by Fb. Okay? Fg is equal to 7.84 multiplied by density of the fluid, which is 1000, divided by 0.98. Density of the object is equal to 8 times 10 to the power of 3 kilogram per meter cubed. So, is this pure gold? Pure gold, guys, density of gold, if you check the, if I'm not mistaken, is equal to 19.8 times 10 to the power of 3 kilogram per meter cubed. So this is pure gold, density of gold. Is this density equal to this one? Of course not. So this is not pure gold. Okay, be careful. Solve question 1 yourself. I'm not going to be solving these questions. I'm going to move on to section review. It says, what is the difference between a fluid and a solid? A fluid can flow and can change its shape, but solid cannot change its shape and it cannot flow too. Which object will float in a tub of mercury? Will float, be careful. All of them are going to float except this one, gold. Why? Because gold is equal to 19.8 times 10 to the power 3 kilogram per meter cubed. It is denser than mercury. Okay, so if it's denser, it's going to sink. Be careful. Question 3 and 4 are for you. Question 5, it says many kayaks are made of plastic and other materials that are denser than water. How are such kayaks able to float? So you know that kayaks are not only made of one material, they are made of composite materials. The overall density of kayaks is greater than the density less than the density of water. Okay? And also the design of kayaks is made in a way that they're going to displace more water. Displacing more water means what? Means a higher buoyancy. So you have pressure. Pressure is equal to force divided by area. Force with pressure are directly proportional. Okay, with area, they're inversely proportional. Be careful. It means if you increase force, pressure increases. If you increase area, pressure decreases. What does pressure depend on? Pressure is equal to force and area. We have Pascal's principle. It says what it says. Pascal says that pressure applied to a fluid in a closed container is transmitted to every point of the fluid and to the walls of the container. For example, you have a hydraulic lift. Okay, if you apply a pressure here, you see that the pressure is going to be equally transmitted to every point of the fluid. Okay, be careful. And we have an equation for this one. We say F1 divided by A1 is equal to F2 divided by A2. Just one simple note. How do you know this one is A1 and how do you know this one is A2? A2 is always, look, A2 is always greater than A1. If it gives you in radius, radius 2 is always greater than radius 1. Okay, even if the question doesn't say. Let's solve the question. Okay, it says the hydraulic lift, the small piston on a hydraulic lift has an area of 0.2. Okay, so it says the small piston, because it says small piston, so I'm going to say this is A1. Be careful. 0.2 meters squared. A car weighing, okay, so if you have the hydraulic lift like that, okay, this is the hydraulic lift, this one is the small piston, okay, this one is A1, this one is F1, this one is F2, and this one is A2. This is where you put the car. So if it is a car weighing, so a car weighing, so it's going to be F2 is equal to 1.2 times 10 to the power 4 Newton. Sits on a rack on a large piston. The large piston has an area, so A2 here, A2 is equal to 0.9 meter squared. It says how large a force must be applied to the small piston. So which force is with the small piston? It's F1. So find F1. F1 is equal to what? Okay. Now you know the equation. F1 divided by A1 is equal to F2 divided by A2. Okay, so multiply because you need to find this one. So F1 multiplied by A2 is equal to F2 multiplied by A1. Okay, you need to find A1, so divide this by A2. Divide the other side 2 by A2. A2 cancels with A2. Okay, force 1 is equal to F2 multiplied by A1 divided by A2. Force 2 is equal to 1.2 times 10 to the power 4. Area 1 is equal to 0.2 divided by A2, which is 0.9. You have 2.7 times 10 to the power of 3. You have force, be careful, so it's Newton. Yeah. Solve the other questions yourself. Just this one, it's really easy. You have width and length, multiply them, you get area, and then find the pressure. Pressure is force divided by area. Okay, pressure in a depth. Okay, I'm gonna simply explain this. It's really, really easy. Okay? Now, you have three types of pressure. Pressure is equal to force divided by area. Okay? And it depends on force and area. Force with pressure is what is directly proportional. With area, it's inversely proportional. This is used in solids, or when you have a mattress or a box, you apply force on this box, you're going to use this equation. But if you have a fluid, can you use this equation? Of course not. Be careful. Let's say we close this container. Okay? We close this container. We have what? We have the height of the fluid. Let's say it's water, so we have density of the water too, and something else is applying a force on this water, which is G, gravity. Now, if you want to find the pressure in this water, you have pressure, which is equal to rho GH. Okay? I call this type of pressure gauge pressure. Gauge pressure. When do you use this equation? When the question says vacuum chamber. Okay, when the question says vacuum chamber. Okay? Or sometimes the question directly says find gauge pressure. Okay? Now, if the container is not closed, okay, let's say you have a container like this, something else is applying a pressure on it, which is, we call it P naught, which is atmospheric pressure. Okay? So if you have, let's say, a closed container like this, you have height, you have gravity, and you have density of the fluid too. I call this gauge pressure. Gauge pressure is equal to rho gravity H. But what if I open this? Also, the atmospheric pressure is applying a pressure on it. So this is going to be what? This also should be taken into consideration and should be also calculated. So I'm going to say pressure is equal to what? P naught plus rho GH. Pressure of this one plus density multiplied by gravity and multiplied by height of this fluid. What do I call this? The question is going to say absolute pressure. Okay? Absolute pressure. Okay? Let's solve a question about this. So if you go deeper and deeper, pressure increases. And if you go higher and higher, pressure decreases. Be careful. Pressure in a fluid depends on three things. Be careful. Pressure in a fluid depends on three things: gravity, height, and density. Okay, this is all for you. I'm going to move on. The device or the instrument that we use to measure atmospheric pressure is called mercury barometer. Atmospheric pressure is basically a pressure exerted by the weight of the air. Okay, let's solve a question. We have this question. It says calculate the absolute pressure. Pressure is equal to what? Because it says absolute, so I know that it is equal to P naught plus rho GH. Be careful. Why? Because it says absolute. At an ocean depth, so depth means height, 11 kilometers. Assume that sorry, it's not 11, it's the other question. So 1 times, it's the same by the way, 1 times 10 to the power of 3 meter. The questions are the same. Assume that the density of the water, rho, is equal to 1.025 times 10 to the power of 3 kilogram per meter cubed. And we know that P naught is equal to 1.01 times 10 to the power of 5. So P naught is equal to 1.01 times 10 to the power of 5 Pascal. Calculate the absolute pressure. So we know absolute pressure is equal to 1.01 times 10 to the power of 5. Sorry, this one, atmospheric pressure, plus density of the water, 1.025 times 10 to the power of 3, times gravity, which is equal to 9.81. Gravity is equal to 9.81. Multiplied by height, which is 1 times 10 to the power of 3. Pressure is equal to 1.02 times 10 to the power of 8 Pascal, if I'm not mistaken. Okay? Okay, now this question is the same, but you have 11 kilometer. Please change it to meter. Don't use it like that in the equation. Okay? I'm gonna solve. This is, by the way, this one here. It says vacuum chamber. So it says vacuum chamber. So you're gonna say it's equal to rho GH. Okay. You need to find height. So height is equal to P divided by rho G. P is equal to what? P is equal to 2.7 times 10 to the power 4 divided by density of the mercury, which is equal to 13.6 times 10 to the power 3 times gravity, 9.81. I think you get 0.202 meters, if I'm not mistaken. Okay, calculate it, please. Calculate the depth in the ocean at which 3 times atmospheric pressure. This is also a good question. Please focus on that too. So temperature is basically the measure of average kinetic energy. The difference between temperature and heat is that heat is the energy. Heat is a type of energy which flows from one material into another, while temperature is the average measure of kinetic energy. And we have this relationship, which is what? Tk plus 273. Okay? And if you want to change Tk to Tc, Tc to Tk, sorry, you're going to add 273. If you want to change Tc, okay, so you want to find Tc, it's going to be Tk minus 273, okay? Question 1 here. Which of the following exerts the most pressure while resting on a floor? So you have sites, okay? You have sites. So you know pressure is equal to force divided by area. Force is equal to 25 because you have 1.5 sites. So 1.5 multiplied by 1.5 measured, I think you're going to get 11 something Pascal. Okay, this one is the highest. Okay, you have radius here. So you're going to say pressure is equal to force divided by area. Force is equal to what? It is equal to 15. But area is pi radius squared. Okay, so 15 divided by pi radius, which is 1 squared. Calculated, I think number A exerts the most force because it's the highest. Okay, this also here. If it says sides, just multiply 2 by 2. Okay, this one says radius, so pi r squared to find the area and use it in the equation. This question is also says water is to be pumped to Safin Mountain, which is 321 meter height. What gauge pressure? Because it says gauge pressure, so you know gauge pressure is equal to rho GH. Okay, height is equal to 321. Then you have density of the water 1000, and then you have gravity 19.81 calculated. And I think it's equal to 3.14 times 10 to the power of 5 Pascal. These questions are for you, please solve. We have fluids in a motion. You have two types of flow when it comes to fluids, laminar and turbulent flow. Laminar flow is when, when every particle that passes through the point moves along the same smooth path. Okay? It means they all have the same velocity and they're all moving on the same path. While turbulent flow, the flow of a fluid becomes, the velocity is not the same. And for example, let's say there's an obstacle in front of it. Okay, so it's going to change the flow of that fluid. Okay, so turbulent laminar flow. Ideal fluid is a fluid that has no internal friction, or it has no viscosity, and it's incompressible. Okay, viscosity is what is the amount of friction within a fluid. Okay, for example, you have oil and you have water. Which one has more viscosity? Which one is difficult to flow? Is more difficult to flow? Of course, oil. You have honey and water. Which one is more difficult to flow? Of course, honey is more difficult to flow. So honey has a more viscosity. Water has less because water can move easily. What are the properties of an ideal fluid? This is really important. No internal friction over viscosity, incompressible, steady flow, density, velocity, and pressure constant at every point, and non-turbulent. Okay. And then we have what? We have principle or equation of continuity. What does that mean? It means the fluid that enters a pipe, okay? The fluid that enters a pipe equals the fluid that leaves a pipe, Okay, and we're going to have an equation for this. We're going to say A1 V1 is equal to A2 V2. Be careful. Now, if the what we call the fluid is entering here, okay, and it's moving with a high speed, because the thickness here is increasing, so the speed here decreases. Okay, so it's of course going to be the same. Okay, the amount of the fluid that is leaving the pipe and that is entering the pipe is the same. We have something called, which is called flow rate. The smaller the cross-sectional area is, the faster the fluid flows. For example, you have a hose in your hand. If you pinch that hose, the fluid is going to move faster. But the flow rate, be careful, is constant. It doesn't change. We say that flow rate is like this, AV1, okay, which has a unit of what? The unit of it is V divided by delta T, which means that the V is volume and delta T is seconds. Okay, most of the time you're going to be given like that in the equation. Okay, Bernoulli principle says what? It says the pressure in a fluid decreases. The pressure in a fluid decreases as the velocity increases. If you cannot remember this, please compare it like this. You are on 120 meters road. The road is really, really crowded. Okay, the road is really, really crowded. Okay, why? Because the velocity is less, so the pressure is going to be high. What if that person who is in front, okay, who is making that crowdness, is moving very, very fast? So the other cars are going to move very fast. So if the objects are moving faster, or the particles are moving faster, it means the pressure is going to be less. Be careful. When you leave your classroom, if somebody, one student, is blocking the door, okay, he's moving very slowly. So slow motion, it means really high pressure in front of him. Okay, all the students are going to pile up on his back. Okay, now, what if he's moving very fast? Every student is going to move very fast, and there will be no pressure in the room or on the door. So high pressure, it means low speed. Low pressure, it means high speed. High pressure, it means low speed. Here, as you can see, the speed is going to increase, okay, and it's going to have less pressure. Here is going to have high pressure because the speed is really low. Okay, explain how can a lift on an airplane be explained in terms of Bernoulli's principle. So we said that Bernoulli's principle, as the velocity of an object decreases, pressure decreases as the velocity of an object decreases. Okay, now how does the lift on an airplane can be explained? So above this, let's say this is the wing of an airplane. Okay, this one here. Above the wing of the airplane, velocity is really, really high. So velocity is high. If velocity is high, pressure is going to be less. But at the bottom of the wing, okay, velocity is going to be less and pressure is going to be more. If the pressure is going to be more, it means it's going to what? It's going to lift the it's going to lift the airplane, this pressure, which is at the beneath the wing. These are some equations that you're going to use in this section. If the fluid is not moving, if it's static, we're going to say P1 is equal to P2 plus rho GH2, static fluid. If it's horizontal, it means we are now going to have height. It's going to be P1 plus 1 over 2 rho V1 squared, P2 plus 1 over 2 rho V2 squared. This is when it's horizontal. Question 3.2. Question 3.2. Question 3.2. A tank has a spigot near its bottom. Okay, so you basically have a tank like this and you have a spout here, okay? And if the tank is open, like it's open up, determine the speed at which the water leaves the pipe. So it says V1 is equal to what? If you know that the water level, whenever it says water level, it means it gives me H2 minus H1. Okay, this is equal to 0.5 meter. Don't give yourself the headache of calculating everything and, writing the equation all over again. When it asks for speed, V1 squared is equal to 2 G H2 minus h1. Okay, now I need to find this one. So v1 is equal to square root of what? Of 2g h2 minus h1. Okay, so we have 2 multiplied by 9.81, and h2 minus h1 is equal to 0.5. v1 is equal to 3.13 meter per second. Okay, that's it. So when it asks for the velocity, use this equation. Okay, v1 is equal to 2g h2 minus h1. Okay, let's solve question 3D from this one, and we're going to end this section, end this review. Okay. It says what? It says that a large store tank open to the atmosphere at the top filled with water develops a small hole inside it at a point of 6 meters below. Okay, so H2 minus H1 is equal to what? It is equal to 16 meters. Okay, be careful. If the rate of the flow, be careful, rate of the flow, I'm going to write it like this. A V1 is equal to what? It is equal to 2 times 10 to the power of negative 3 divided by 60. And then the unit is meter cube, per second. A, V1 is equal to what? I just said that V1 is equal to what? 2G H2 minus H1. Okay? Calculate this. 2 times 9.81 times H2 is equal to 16. So if you calculate this, V1 is equal to 18 meter per second. Okay, this is the what? The V1, the speed at which the water leaves the hole. B, it says calculate the diameter. D is equal to what? Okay, diameter is equal to what? Now, this is distance. Let's say diameter. D capital is equal to what? So you know diameter is equal to 2 multiplied by radius. I don't have the radius. How can I find the radius? Okay, area is equal to pi r squared. Okay, but I don't have area too. Okay, so what can I do? Okay, what can I do? So you know that speed is equal to 18 meter per second. So I'm gonna delete this. Okay, I'm gonna delete this. Question B, diameter is equal to what? Okay, diameter, D capital, is equal to what? So you know diameter is equal to 2r, but to find the this one, the diameter, I need the radius. Okay, how can I find the radius? To find the radius, I need the area. Okay, I don't have the area too. How can I find the area? Look at this one, guys. So A V1 is equal to 2 times 10 to the power of negative 3 divided by 60. So divide this by V1 and divide the other side too by V1. V1 cancels with V1. A is equal to 2.5. This is 2.5. Be careful. 2.5 times 10 to the power of negative 3 divided by 60 divided all by V1. We found V1. V1 was equal to 18. Okay. Now area is equal to what? Area is equal to 2.3 times 10 to the power of negative 6 meter per second squared. Now let's use that in the equation and find radius with it. So I need radius, so divide this by pi and divide this one by pi too. Cancels, cancels. Radius squared is equal to area divided by what? By pi. Okay, take the square root for each one of them. Cancels, cancels. Let's do that here. Radius is equal to square root of area divided by pi. Radius is equal to what? I found area 2.3 times 10 to the power of negative 6 divided by pi. Okay, radius is equal to 8.85 times 10 to the power of negative 4. I found radius. Let's find the diameter. Diameter is equal to what? 2 times 8.85 times 10 to the power of negative 4. If you calculate this, diameter is equal to 1.71 times 10 to the power of negative 3 meters. This is question 1 from practice 3-2. I'm going to leave the other questions for you. This is it, guys. This is the full revision of the first semester of grade 10. I hope this really benefits you, and I hope that you succeed with grade marks in this exam. So until the next video, see you and good luck in your exams.